Um, I'm going to introduce a new conditional probability notation here. It's part of the Q notation, and what this, whoops, sorry about that. And what this notation means is the probability that a newborn survives to age x plus n, but does not survive to age x plus n, given the fact that they survive to age x. So it's a conditional probability statement. So we can actually read it more simply. The probability that age x survives n years, but not n plus m years. Now, since this is a conditional probability statement, we can write it using our rules for conditional probability. So the probability a newborn survives to age x plus n minus the probability a newborn survives to age x plus n plus m would be the probability that a newborn survives between those two ages, and then we can divide by, whoops, I don't know what happened there, and then we can divide by the probability of the condition being true, that a newborn survives to age x. We then want to use our multiplicative properties of probability, so this would be what, P0x, probability survives to age x, and then age x survives n more years. And the second term we can rewrite, newborn survives to age x, and newborn survives, or age x survives n plus m more years. Using the multiplicative property, we see that we can then factor out the probability a newborn survives to age x and cancel it, and we're just left with the probability age x survives n years minus the probability age x survives n plus m years, and that is our new notation, an interpretation of our new notation. We can also go ahead and use a multiplicative of probability again on the second term and factor out a pxn, the probability x survives n more years, and then age x plus n survives m more years. That would be how x could live n plus m more years, and factor out a pxn. And you see we now have the product of a p and a q, pxn times q x plus n m. So this is another way to write this conditional probability statement. Now the most commonly form used of this new notation is written down here. The probability that alive at age x fails in the n plus first year. Notice we suppressed the 1 after the vertical bar. So if I want to draw a timeline here, I have your currently age x, you survive n years, and you fail or die in that interval. If I drew the timeline up here for this notation, age x would survive n years and die within, and this is age x plus n, by the way. I guess this would be age x. If I'm doing age here, that would be age x plus n, and this would be x plus n plus 1. So you would survive, if this is ages, you would survive to age x plus n, but not to x plus n plus m. So you would die in here. So that would be the event for which you're finding the probability above. And then here you're finding the probability for dying in that 1 year interval of time. Okay, so let's see. Let's go ahead and determine one of these with an example. The probability a 1-year-old survives 1 more year, but then dies in the 2nd year. So that would be what? survives 1 year, so then the 1-year-old would be 2 years old. So this would be the number of 2-year-olds dying within a year, divided by L1. So this is how we would calculate it in our life table. And if you do that calculation, test yourself out, I believe you should get this probability. If we wanted to write this another way in terms of P's and Q's, this would be the probability that a 1-year-old survives 1 year, right? And then that 2-year-old dies within a year. Suppressing the ones, probability 1-year-old survives a year and a 2-year-old dies within a year. So we could just take that product and also arrive at this number. A couple of comments here. This is 6.3.3, this new notation we've talked about. 6.3.1 discusses mu x and mu x plus t, in other words, the hazard rate function or the force of mortality. And you just get, using the life functions, that we know that the hazard rate is a derivative of this negative, the derivative of the survival distribution over the survival distribution. So we can just write that in terms of the life function. That same identity simplifies to this. And 6.3.2 discusses the expected future lifetime, which we've already discussed. So it discusses these two in terms of the interval. And so 6.3.3 we discussed above. Now one identity to keep in mind that's also discussed in Chapter 6, but we discussed it in Chapter 5, is my hazard rate function is the ratio of the PDF and the survival distribution function, which is, we can write like this, the PDF over PXT. So the PDF can also always be written as the product of the survival distribution function and the hazard rate function. So we already know that. The book goes ahead and discusses it in Chapter 6 as well. But this is certainly an important identity for the PDF that we always need to keep in mind. We'll be using that throughout the semester. And again, if you want to remember this, why this should be the PDF is you survive X survives T more years, and then at age X plus T, they're hit with mortality and they die. So they die in the next instant. So that's another way of thinking of an interpretation of the PDF. Okay, so this should be part 1 together with part 2 should be a pretty complete discussion of Chapter 6.